going to do an induction proof, and what we're going to look to prove is that the triangular numbers are given, the nth triangular number is given by a certain sum. Okay, and we're going to represent that as such. So Tn is equal to n over 2 multiplied by n plus 1. Okay, so what are the triangular numbers? So we start with 1, and then we add on 2, then we add on 3, then we add on 4, then we add on 5, and so on, and they form this triangular shape. Okay, so the first triangular number is 1. So what we do for an induction proof is we check that T1, so we know T1 is equal to 1, and then 1/2 1 plus 1 is equal to 1. So this works for n equals 1. Okay, and then next up we do an anchor step. So we're going to assume for some n equals k that tk is equal to k over 2 k plus 1. Okay, and then we're going to consider k plus 1. Consider n equals k plus 1. Okay, and this is the formula that, not the formula, the recipe, I guess, we use for all induction proofs. So we know that tk plus 1 is equal to tk plus one more term, and that term is k plus 1. Okay, so you see, because on the first term we add in 1, on the second term we're adding 2, on the third term we're adding 3, so plus k plus 1. We've assumed that tk is equal to k over 2 k plus 1, and then we've got plus k plus 1, and we're going to factor out this k plus 1. So that's k over 2 plus 1. And then we're going to factor out this half, so that's equal to 1/2 k plus 1 k plus 2. But we notice here the k plus 2 is k plus 1 plus 1. So this formula works for k plus 1, given it works for k, and since we've shown it works for 1, it therefore works for 2, 3, 4, 5, 6, 7, 8, so on, and that we can continue that logic forever, and therefore we've done our proof. You'd be required on an exam or whatever to write some sort of closing statement just to justify this, just a couple of lines, and explain your steps as you go along. But obviously I don't have much room here, so I just did the math. A couple of questions on this method. So this step here, I believe, is obvious, but how do I know to factor out this k plus 1? Well, it just seems as a k plus 1 in each term seemed like the logical thing to do. You're just trying to rearrange this into the correct form, and then I notice that once you take this half out, you're going to get a 2 here, which is what we want to get this result here. Okay, so just a bit of trial and error really, but the more you do with these, especially these type, because this is, despite being a question about triangular numbers, it's a question about sums. The other way this question could be formulated is to prove for all n that this sum is equal to 1/2 n plus 1. Okay, it's exactly the same question. You can consider why that is, and on exams you might get a lot of summations and be given be given a formula to find those summations, and this is the procedure you have to follow. Sometimes the manipulation is a little bit trickier, but yeah, make sure you get lots of practice in if you did struggle with this example. thank you very much for watching this video. If you did enjoy it, found any utility in it, please be sure to subscribe to the channel. Any support is much appreciated, and I hope to see you in the next one. Have a good day.